Hi, geometry students. Today we are going to be discussing the angle addition postulate. But first I want to remind you of what the segment addition postulate was. Remember, the segment addition postulate stated that if you had 3 points on a line and B was in between, then AB plus BC would equal AC. Part plus part equaled the whole. But remember, we could only use the segment addition postulate if the two parts in question did not overlap and there were no gaps. And then we could say part plus part equaled the whole. Before I get to the angle addition postulate, I want to give you a little vocabulary that you're going to need. Whenever we have an angle, remember, this is a ray, and this arrowhead means it goes on and on and on forever. This arrowhead means it goes on and on and on forever. So the interior points will also go on and on and on forever. So points that are on the interior are bounded by the two rays, whereas all these points are exterior. And now I can use the language that I need to tell you about the angle addition postulate, which you'll see has a lot in common with the segment addition postulate. Same basic idea, but with angles. So if point B is on the interior of AOC, angle AOC, then the measurement of AOB plus the measurement of BOC equals the measurement of AOC. Part plus part equals the whole. The measurement of the yellow plus the measurement of the blue equals the measurement of the black AOC. And just like with the segment addition postulate, we can only use this postulate if the two angles in question do not overlap and there are no gaps, just like with segment addition postulate. So this angle ends right where this angle begins. There's no gap between them and there's no overlap between them. And when we use the angle addition postulate, a lot of times we can apply our algebra skills. So if you think you're all set and want to practice this on your own paper, go ahead. Otherwise, feel free to watch a full example before you go off on your own. So here we're told the measurement of angle ROT, this whole big angle is 155. We're told the measurement of ROS is 4x minus 20. And we're told the measurement of SOT is 3x plus 14. And if you were just given this, you always want to write right on your diagram first thing. Now, these two angles do not overlap and there's no gap between them, so we can use the angle addition postulate. This angle measurement plus this angle measurement will equal this whole angle measurement. So we use the angle addition measurement to create our equation. Part plus part equals the whole. And then we used our geometry truth to create an equation, and now we use our algebra skills to solve. To solve this equation, the first thing I would do would be combine like terms, and then I would use inverse operations to isolate x. The first inverse operation would be to add 6 to both sides, and the next inverse operation would be to divide both sides by 7, and then you get x equals 23. Now, the original question asked us to also find the measurements of the angles, and each angle had an algebraic expression, but we've now found x, so you can plug it in, and get the final measurement of your angle. You can also do a check step. We know that we were told that the whole angle both angles together had to add up to 155, and so you could do a little check step and make sure these two numbers do, and they do, check. So now feel free to pause the video and practice on your own paper and then press play for the solution. So we can draw our algebraic expressions right onto our diagram. We can use the angle addition postulate because these two angles do not overlap. There's no gap between them. So part plus part equals the whole. We use the angle addition postulate to create our equation, and now we use algebra skills to solve. We combine like terms, and now we use inverse operations to solve for x. Add 1 to both sides and divide both sides by 6 to get our answer. Now in this problem, in the original problem, they wanted us to find measurements, so you plug that x in to get our final answers. You could do a check step knowing that these guys have to add up to 131. Check. So pause, practice on your own paper, and then press play for the solution. The first thing you have to do is remember what a straight angle is. So the first thing we have to do is use the definition of a straight angle. We remember a straight angle is an angle whose measurement is 180. Once we know that, we can use the angle addition postulate because these two angles, one ends where the other begins. They don't overlap, there's no gap, so we can say part plus part equals the whole. And the whole is the big 180, is the straight angle. Now we used our geometry, both the definition of a straight angle and the angle addition postulate. We used both of those things to set up our equation. And now we're going to use our algebra skills to solve for x. First thing we want to do is combine like terms. Then we want to use inverse operations to solve for x. The inverse of subtracting is adding. We add 2 to both sides. The inverse of multiplying is dividing. We divide both sides by 13 and we get x is 14. And we can plug in to find the angle measurements. If we've done it correctly, those two angles will add up to the straight angle, and they do, so check. Pause the video, practice on your own paper, and then press play for the solution. In this case, we are told that the whole big angle QTR has this algebraic expression, but we're told these two little angles have those degrees. So QRS is 15 degrees, SRT is 30 degrees, and together so we can use the angle addition postulate because there's no overlap and there's no gap between TRS and SRQ. So we can say green angle plus pink angle equals 45 degrees. And we know that we can now use our angle addition postulate. This angle plus this angle equals the whole. And 15 plus 30 combined like terms is 45. And now we can use our algebra skills to solve it. Use our inverse operations. Inverse of plus is minus. Inverse of multiplication is division. And we get our final answer, and we can plug it in and check. We know that this algebraic expression has to equal 45, so when we plug it in, it does. Check. Pause the video, practice, and then press play. We can mark our diagram. We can use the angle addition postulate to set up our equation, and then we can use our algebra skills to solve. Combine like terms, inverse operations, and then plug it in to get our angles. Pause the video, practice on your own paper, and then press play. Now in this particular diagram, we're given that the angles are congruent. And so the first thing we have to do is use the definition of congruency to create our equation. Congruent angles are angles with the same measurement, so we can set those algebraic expressions for their measurements equal and solve for x. We're going to do inverse operations to get all our variables on the left, and then all of our constants on the right. And then we'll do inverse operations to get x alone. The inverse of multiplication is division. Remember, a negative divided by a negative is a positive. And then we can plug that in to figure out our angle measurements. And I would do the check step of plugging it into both algebraic expressions to make sure you get the same thing. Because if you did it right, you should be able to plug in and they should be the same because we're told they're congruent. So that's a good way to check. So pause the video, practice on your own paper, and then press play. Now, the key to this problem is we're told it's a right angle. So the first thing we have to do is use the definition of a right angle, which is an angle that is 90 degrees. And we're given an algebraic expression for this angle and a different algebraic expression for this angle. And we know that the whole angle is 90 because of our definition of what a right angle is. And we can use the angle addition postulate because there's no gap between these two angles and there's no overlap. So part plus part equals the whole. We can use angle addition postulate, combine like terms, use inverse operations to get x alone, and then plug it in to find the angle measurements. You might want to also do a check step. You know those two angles have to add up to 90 if we did it right because we're told it's a right angle. And they do. Check. All right, pause the video, practice on your own paper, and then press play. Now for this one, you've got to be on your toes. Beware of extraneous information. We are given that AOB and COD are congruent. That's what those scratch marks mean. And that's all we need are those two expressions. So the information about BOC is dead to us. We don't need it for this problem. We can simply say congruent angles have the same measurement. So we can use our definition of congruency to set up our equation. And then we can solve it. We have our equation. We use inverse operations to get our variables on the left and our constants on the right. Subtract 2x, add 2. And now we use inverse operations to get x alone. The inverse of multiplying is dividing, and x equals 8. So pause, practice on your own paper, and then press play. Now this one took a little bit of logic and thinking things through. This time they want us to find x and then the measurement of angle 3. Now the key to this problem is noticing that angle 1 and angle 3 have the same scratch marks on them. That means that angle 1 and angle 3 are congruent to each other. And we know the definition of congruency tells us that if they're congruent angles, they have the same measurement. And so this algebraic expression for measurement of angle 1 will be the same algebraic expression for the measurement of angle 3. So when we mark our diagram, we can put it on both. If they're congruent, their measurements are equal, and their measurement is x plus 1 for this problem. And we were told in the given that measurement of angle 2 is 5x plus 5. So we can write all our given on here. We were told that the big angle PTS, we were told is 147. So all our information we can draw on our diagram. And we notice that these three angles are all right next to each other. There's no overlap and no gap. So we can use the angle addition postulate to set up our equation. Part plus part plus part equals the whole. Now we can use our algebra skills to solve, combine like terms, and then use inverse operations to get x alone. And then plug that in to figure out what we were asked, and we were only asked to find measurement of angle 3. And so I will leave you with this adorable picture of the kittens, and I will wish you a great day.